The Force. By now I'm sure most people know what the Force is. It's that magic Jedi use in Star Wars that let them do cool stuff like jump, lift rocks, float fruit, and pull yourself back into a spaceship. But have you ever wondered, how does it work? How does the Force actually work? Well, let's answer that. Star Wars attempts to answer this question in multiple ways. In Episode 4, A New Hope, Obi-Wan says, "The Force is what gives a Jedi his power. It's an energy field created by all living things. It surrounds us and penetrates us, and it binds the galaxy together." Okay, so it's an energy field. Simple. Except not really. In Episode 1 of Phantom Menace, Qui-Gon Jinn is talking about the Force to Anakin Skywalker, and he mentions midichlorians. When Anakin asks what midichlorians are, Qui-Gon says this: "Midichlorians are a microscopic life form that resides within all living cells. We are symbiotes with them. Without midichlorians, life could not exist, and we would have no knowledge of the Force. They continually speak to us, telling us the will of the Force. When you learn to quiet your mind, you'll hear them speaking to you." Okay, so now there's this thing called midichlorians that somehow tell Jedi what to do? Well, that doesn't help much. And the Star Wars movies don't really help much more than this. But Obi-Wan said something interesting. An energy field created by all living things. We have things in our world that create energy fields. Magnets. Magnets create a magnetic field, and if you think about it, magnets are pretty similar to the Force. Magnets can make things move without needing to have them touch. For example, look at this. I can move this magnet around a piece of paper and match it. How is it moving? Well, there's a magnet on the back. But it even works with larger distances. I have a magnet in my hand, and underneath my hand I have another magnet. Watch as I flip the magnet under my hand. It causes the one on top to flip too, even though they aren't even touching. Electricity is very similar to magnetism, in the sense that it can make electric fields and influence objects and give them a charge without actually touching them, a process called induction. I believe this is how the Force works in Star Wars and how it could sort of theoretically work in our world too. The Force, more specifically the midichlorians, can create electric fields and polarize objects, meaning that they can separate the charges within said objects. Just to illustrate what I mean further, if you have a material with all these positive and negative charges, and you introduce an object that has, say, a negative charge, all the positive charges will attract towards it, and all the negative charges will be repelled from it, polarizing the object. So, with this in mind, it's time to calculate some forces. The scene of Force usage I'll use is when Luke Skywalker is training to use the Force with Jedi Master Yoda on Dagobah. In the clip, Luke Skywalker uses the Force to lift up a small boulder and set it down into a smaller boulder. What I need to do is figure out how high the rock was lifted, and to do that, I need to do a lot of guesstimating and a lot of math, so pull out your calculators. Actor Mark Hamill, who played Luke Skywalker, is 5'9", or 1.7526 meters. In this scene, Mark is standing on his outstretched arm, so I needed to figure out how long his arm is. The way I did that was I found a picture of Mark Hamill where I could see his whole body and one of his arms was straight. I then put a ruler to my phone screen and measured how long Mark Hamill was, which came to be 2 inches. I then measured the length of Mark Hamill's arm on my phone, which was 0.625 inches. Dividing the length of the arm by Mark Hamill's total height gave me a proportion for how long his arm is in relation to his body. Mark's arm is 31.25% of his height, so multiplying this by 1.7526 meters gave me 0.5476 meters. So adding this distance to Mark's height gets how tall he was when he was standing on one arm, which is 2.3 meters. Now to see how high up the boulder is lifted. It appears to be lifted right up to the joint of his arm, so I'll stick with that. That means the rock is lifted 0.5476 meters. The next step is to see how long it takes Luke to lift up the rock to that distance. I timed this 5 times to get an average, so it wouldn't be too inaccurate. The average time I got was 3.792 seconds. The next step is to calculate the velocity of the boulder and the acceleration. Now that I have the time, I can very easily find the velocity just by dividing the distance by time, which gives me 0.1444 meters per second. Now to calculate a force, I need an acceleration, which I can find easily. I can use the motion formula, change in position equals initial velocity times time, plus half of acceleration times time squared. So plugging the numbers gets 0.5476 equals 0 times 3.792 plus 0.5a, 3.792 squared. The initial velocity is 0 because the rock starts out as not moving. Calculate that down, and the acceleration becomes 0.076 meters per second squared. Now, here's where we run into a bit of a problem. The general equation for force is force equals mass times acceleration. I need to find the mass of the rock Luke lifts. I can find the mass of the rock by using the equation density equals mass divided by volume. But there's a problem with that. How the flurp do I find the density and volume of this rock? A lot of assumptions. For the density, I just used the average density of a rock, which is 2,650 kilograms per cubic meter. For the volume, I made the very rough estimate that the rock is a cylinder whose height is the same as the radius. I also assumed that the diameter of the rock is the same as the length of Luke Skywalker's head, so to figure that out, I used the same scaling technique that I did to get his arm for the head. I calculated the rock's diameter to be 0.3012 meters. Half of this is the radius, which is 0.1506 meters, which I also estimated is the height of the rock. So plugging all this into the equation for finding the volume of a cylinder, 2 pi radius squared times the height, I get a volume of 0.0215 cubic meters. To solve for mass in d equals m divided by v, I just needed to multiply v by d, which is 55.65 kilograms for mass. And now finally, multiplying the mass by acceleration, I get a force of 4.229 newtons. So there we go. How much force is the force? 4.229 newtons by my calculations. There were a lot of other scenes using the force that I wish I could have done, but unfortunately due to time restrictions I wasn't able to. That's it for me. Thank you for watching, and may the 4.229 newtons of force be with you.